ठीक है, आसान समझा। मैंने तो देखा भी नहीं कि क्या है, क्या मतलब हाँ ठीक है, सीजन वाले को चलो देख लो सीजन में वो प्रोसीजर क्या है उसका। अरे नहीं, वो तो वो रखा रहा है, टेक्स्ट होता है। सीजन वाला क्या था? अरे सीजन से डायरेक्ट करते हैं ना, होता है ना कि सीजन का उसमें प्रोसीजर क्या पहले ऑक्सीडाइजर होता है, रिएक्शन होता है उसमें, टीसीडी का बोला होता है, इससे डायरेक्ट करके वो डेटा और तुम्हें पता नहीं का फिर क्या था, वही कल हम लोग डिस्कस करते हैं। हाँ, ओपन कोर किकिंग कोर ये पूछ लूँगा, किकिंग कोर ने बोल मत उसको मेटल एक लास्टर वास्टर था उसको। नहीं आ तो रहा है भाई, काफी लोग आ रहे हैं। शुरू कर दो क्या? Hello, good afternoon. Can please anyone tell if I'm audible or not?
Yes, you are quite audible, Debarun. You are quite audible.
Okay, thank you. Uh, we'll just wait a few more minutes to let anyone join and then we'll start our discussion.
Sure, no problem.
अलग तो हो गया। यहाँ पे रख तो मेरे को पूछना। नहीं, मैंने अभी कंफर्म नहीं किया, मैं सोचा नहीं कंफर्म करूँ फिर मुझे रखे हुआ है को यहाँ ही दो है इसमें। Okay, so good afternoon all. My name is Devarun Banerjee and I am one of the teaching assistants for this course in NPTEL for the name is Technologies for Clean and Renewable Energy Production. And so what we are going to do is uh, we are going to discuss about what has been taught in the first week, and then some of the sample problems we'll try to address and also solve them, and also will be open the flow for further questions. So good afternoon again, and the first lecture which has been taught by Professor Mandal, it had been and a kind of introductory lecture regarding the overview of what is the basically importance of energies in the sustainable development, energy as an indicator of development, and an overview of the world energy scenario regarding that the energy consumption, the different variables of energy, and what can be the future perspective. And furthermore, from an Indian perspective also, the same things were also discussed, like the energy consumption, types of energy, and the future perspectives. And further, then to correlate with that particular future perspective and the requirement of the energy development program, uh, the further requirement of the clean and renewable energies was also a briefly overview was provided, and also the different routes of clean energy production, different types of renewable energies, and also the importance of energy conservation. These are all discussed. If anyone has any kind of doubt or any kind of discussion, everything is welcome from the first lecture. Okay, if there's no doubt, then move to the second lecture. The second lecture majorly focused on the coal as a basic energy source. The coal is and its basic composition, the origin of coal, its rank, energy content, different types of coal such as anthracite, bituminous, lignite, peat, and how they are basically kind of the availability of the coal uh, worldwide also, and also in Indian market also, like what kind of coal is available in India, and that actually very much depends and also affects the energy production and electricity generation from it. Also the different properties and pricing of coal, and finally the energy production perspective from coal. These are all discussed here. Again, if there is any question, I'd be happy to resolve. If not, then the third lecture was basically the characterizations, like the proximate and ultimate analysis of coal, and also the calorific value estimation of coal via basically a bomb calorimeter, and how some of the numericals were actually discussed. The basic characterizations like proximate analysis will give us the moisture content, volatile matter, ash content, and the fixed carbon, whereas the ultimate analysis will give us the elemental composition such as CH, N, S, and O, the basic elements of an hydrocarbon. And also the when we talk about the energy production from coal, the electricity generation, we need to get that how much energy can be produced from a coal when we are burning it, right? So that is the calorific value estimation or the heating value estimation by the bomb calorimeter experiments are also discussed here. Furthermore, the fourth lecture was basically a coal-fired power plant was discussed, when there is a combustion of coal, and the power generation was discussed here, and also some the overall plant efficiency, some of the Carnot efficiency, Rankine cycles, Breton cycles, this kind of thermodynamic cycles are also discussed, and overall performance of coal-based power plant, how to quantify it, how to quantify based on the efficiency, how to quantify it based on the energy production in terms of maybe kilowatt hour, and then also the some of the IGCC cycles, which is actually the newer technologies. These are also discussed, and some of basic fixed bed and fluidized bed reactor and their process conditions and efficiency were also discussed here. These are the overview of the 4 lectures basically, which has been taught in the week 1. This first live session is all about basically this first week teaching, and if there is any doubts and some of the sample problems, some of the sample questions we'll be discussing, and apart from that, if you have any queries regarding the course and all, you can ask directly to me. There are also some new people who have joined. Can anybody among the new people confirm if I am visible and audible to them? And if the
Yes, sir. Yes, sir.
okay, okay, great. So far, what I have just told as a very brief overview of the 4 lectures. So, and apart from that, there was also one tutorial which was also provided. The some problems were actually solved in the tutorial video. So, also if you have any doubt in that tutorial problems, also you can also we can also discuss. Okay. So moving on, we'll be discussing some of the questions, sample questions, basic questions, uh, which are also provided as the assignment 0 to you. So the first question is, the Kyoto Protocol is related to what? CO2 reduction, solar energy, water management, or women empowerment. So let's do this in an interactive way. So what do you think? What would it be? Anyone?
Yeah, it's CO2 reduction.
Yeah. So it's correct. It's this is very simple. The Kyoto Protocol is actually related to the CO2 reduction, which is the actually nowadays the basic theme of the climate change actions, right? To reduce the carbon level in our atmosphere, ultimately, which can actually correlated to the global warming. This is the target to limit the temperature increase of the global temperature increase beyond 1.5 to 2 degrees Celsius. The next one is that in India, the city number of diesel used in trucks may be about what it is, 5, 14, 45, or 85.
45.
Yeah, so the correct answer is 45. The city number of diesel basically shows us the performance of the engine. The calorific value of dry wood may be around, what would be the calorific value of dry wood?
5,000.
Yeah, it's 5,000 kilocalories per kg. Remember, the dry wood actually been used for for uh, for a long time back also as a fuel for cooking purpose and all.
So for the question on the cetane number,
Yeah.
can we calculate this number with the formula of cetane? Uh, can you elaborate a little bit on that?
Yeah, you can like this octane number, a cetane number. These are obviously the calculative one, right? The anti-knocking and knocking and anti-knocking properties we can see by this octane and cetane number. So there is a empirical correlations, and uh, you can actually calculate that for the diesel discuss the certain number is that's why useful, that because the engine performance is actually important to know via the certain number. Another question there is in chat. So do we have to remember such calorific values? Yeah, I don't think so, but some basic ones might be you'd be better knowing the range of them, uh, so that because if it's an like this multiple choice ones, so you'd be it would be beneficial for you, right? Maybe in a comparative way. Because why I'm saying this is so that the next question is that the calorific value of LPG gas is around, what is it, 1000, 5000, 10,000, or 12,000? So when we're talking about the comparative ones, it's actually far greater than the dry wood, right? So that's the thing. So it's not very mandatory to remember very much details of numerical values. It's just a brief introductory kind of some questions to know about the basics of the energy. Uh, Another thing is that which of the following is called a blue gas? The coke oven gas, the water gas, natural gas, or producer gas?
Water gas.
Yeah. So yeah, the answer is right. It's water gas, which is actually a very important one from also the industrial perspective. The LPG constituents gases are four options: methane, butane, methane, propane, butane, propane, and propane and pentane.
Butane and propane.
Yeah, so that's the correct one. It's butane and propane. Uh, the other question is that which of the following sources is responsible for maximum air pollution? This is a kind of, you know, based on the data of the pollution control board also. That's the industrial chimney exhaust, forest fire, automobile exhaust, or bacterial action. It might be a bit controversial, but it is what it is. So what according to you would be the highest responsible thing?
Automobile exhaust.
So we need talk about the, yeah, it's actually in general way it's a correct one. First of all, the second thing is that what do you all think that is it correct to generalize this particular thing, that it is all it would should it be always or let me reframe the question like that, is everywhere would it be same like the industrial chimney exhaust or automobile exhaust, uh, like always automobile exhaust would be greater or what?
Probably the answer is arrived at data, and the data would have been arrived considering the population and the number of vehicles and automobiles data is available. So, such number of automobiles, if they are being used in n number of hours in a day, would release the pollutants. So, considering that, probably the Pollution Control Board would be having some data based on which it has been concluded that it is the it's the automobile exhaust causing the highest and not the industrial chimney exhaust.
Yeah, yeah, it's obvious that the data is actually the thing. This is a generalized one, but my point is that if we segregate like the different sectors of maybe one area, one such area where this majorly the industrial activities are more, or less automobiles, like the less population. So there might be a difference of this. So it's a bit of controversial. Obviously, the data says the last thing, and say data has the last laugh also. So moving ahead, yeah, please.
You have mentioned it right. Probably the industries should be contributing the pollution, but not as the greenhouse gas pollution, but overall pollution of the
Yes.
liquid air pollution and the solid waste and all that together. If is considered, it comes to an understanding, a fair understanding that industries of this current world, as you know, the global growth is also moving ahead on industrialization. Like country like India is moving ahead on a rate of 5 to 6% growth on industry for say next 10, 20 years. That would definitely add more pollutants. So the emphasis more should be on the pollution control board should put more regulatory on to see that they should adhere to the norms.
Yeah, very well said. Uh, it's absolutely important to know that this kind of also the different norms and what kind of regulatory actions are also have to be taken to also control this kind of air pollution. So the SO2 present in the industrial chimney exhaust gases cause what kind of problems? Does it cause respiratory lung disease? Does it reduce the plant's productivity due to causing an acid rain? Does it corrode the building materials? Or each and every options are correct?
All of the above.
Yeah, quite right. Uh, all of this, like the SO2 actually gets converted to H2SO4, and then ultimately pouring as an acid rain, and the corrosion again via this acid rain, and also the SOx which are present in the atmosphere, they actually cause the corrosion also, and obviously when you inhale even at a ppm level also, then it causes some diseases also, like the respiratory and lung diseases. So all the above actions are correct. Uh, the LED bulb consumes more than how much percentage less energy than the incandescent light? 50, 100, 75, or 25? So the uh, answer is correct answer is the 75% less energy consumption is there when we are using the LED bulb compared to the incandescent light, and that is why probably the basically the even if the capital cost or the market price of the LED bulb is greater, far greater than the conventional light also, the more longevity of this kind of LED bulbs and less energy consumption is actually uh, the main major, the reasons why basically the LED bulbs are getting more and more used in all of the places, because overall the overall cost if you are talking about, and also this energy consumption, it again this correlates with the cost. So overall the cost and overall the sustainable development point of view also, this LED bulbs are very good.
Mhm. You mentioned it right. Actually, when we go back to our early times, there were incandescent lamps and tube lights and the other bulbs. They were contributing to huge energy. If you compare that with LED bulbs, energy is less by 75%. Means we are contributing a lot to sustainability. And I mean, it was the invention of it was a revolutionary invention actually, and I think I heard, maybe I'm not sure, but the scientist who was onto the invention of LED bulbs was also a Nobel awardee. Also, I heard some years back. So this is a revolutionary change which has brought a lot on energy conservation. And every household, if they switch over to LED bulbs, would definitely make a big change for sustainability.
Yeah. So great elaboration, uh, and that is actually like the sustain when it also the Professor Mondal has discussed in one of the, I think, introductory lecture also. This is a brief comparison between the conventional bulb CFL and the LED bulbs. So we are trying to move towards this LED ones. The term trans-esterification is related to what? Pyrolysis, combustion, biodiesel, or tidal energy? Very simple question, I think.
Biodiesel.
Yeah. So it's again a very simple question, that when we're trying to produce basically biodiesel uh, via this via the the fatty acid esters, this trans-esterification reaction actually occurs, and then we are producing the biodiesel again. The world's largest floating solar energy project is to be constructed at anyway it's in the assignment 0, but it's more like a geography question anyway. So the where is it? The Hirakud Dam, Tehri Dam, Omkareshwar Dam, or the Sharda Dam? So it has to be constructed as the Omkareshwar Dam on the Narmada River. Is the world's largest floating solar energy project. Uh, India aims to achieve how much quantity of coal gasification target by 2030? Is one of the targets which have been discussed in our energy policy also. It's 50, 7,500 or 125 metric tons of coal gasification. So it would be like 100 metric tons of coal gasification is one of the portions which I think you would be taught in the second week lectures. It's a very important, even if we are currently trying to rely on this renewable energy source. The coal is still the major power source. It also tells us this kind of, the data also tells us this kind of information also.
Sorry for the interruption. It's not metric ton, million tons.
Yeah, sorry, 100 million tons. Sorry. The largest wind energy production state in India, it's Gujarat, Rajasthan, Maharashtra, or Tamil Nadu. It is Gujarat, the largest wind energy production state in terms of overall the renewable energy, also the wind energy, along with the other solar energy, biomass energy, also the tidal energy. It's one of the very important aspect, and especially with this coastal areas or this windy areas at a certain height, this wind mills you can see. Uh, so the Gujarat is having the largest wind energy production so far within India. The pivotal source of energy in Asia Pacific region is nuclear energy, wind energy, coal, or solar energy. So far, what is the major source of energy in our basically this Asia Pacific region?
Probably coal.
So yeah, you're correct. Again, so far as again the same thing that even if we are targeting to move towards the still coal having the first place as a major source of energy, at least in the region we are currently residing, the Asia Pacific region.
And globally, I think it is 60% contribution on a
Yeah,
global level.
yeah. Thank you for the information. Uh, the next question is that the what kind of biomass based seed is actually used for the biodiesel formation, majorly because the different kind of seeds having a different kind of oil content, and uh, and also this basically what it contains is that those fatty acid, and which would ultimately gets converted to the biodiesel. So what kind of seeds like cocoa seed, jatropha seed, jackfruit seed, or wheat? It's a jatropha seed. Maybe many of you have heard of this kind of jatropha oil also. So it's very useful for biodiesel formation again. Now moving on to what's the some other questions which are directly discussed in the lectures. It would also uh, you know say the capability of how much I have seen this the lectures also, because everything has been taught there. The questions we are going to discuss, it would be kind of a practice questions. The gross domestic product GDP is having a correlation, or it's basically is dependent on the consumer spending, government spending, countries business spending, and the net exports. So what do you think this particular correlation uh, in between them and with the GDP?
Probably the fourth one, all positives.
Yeah, you're correct. The more and more economy flow will be there within the country, which means the government spends more, the consumer like us, we spend more, and overall the business we are doing as a country, and the quantity of our currency we are able to deal with the other countries in terms of exports. So all of these factors are important, and all of these are proportional with the GDP. So the correct answer is the fourth one, all positive. uh, Again another question. The which of the following countries has the highest carbon dioxide emissions among Russia, China, India, and Brazil?
Probably China being the uh, country of biggest population and high industrialization.
Yeah, that's right. The China is the major contributor in the CO2 emission among in the CO2 emissions. Now, can you correlate between the coal type and the corresponding carbon percentages. There is a lignite, subbituminous, bituminous and anthracite types of coal and the corresponding different carbon percentages. What do you think would be the correlation?
Starting with the least carbon percentage, it is the lignite. So the next in the rank should be subbituminous, and then bituminous, and the last being anthracite, having the highest carbon percentage.
Yeah, absolutely spot on. Uh, this is actually the coal type is actually written in that order only. You have to just correlate with the corresponding carbon percentages. So P3 means lignite having a usual carbon percentage between 25 to 35 percentage, subbituminous between 35 to 45 percentage, bituminous having 45 to 86 percentage. So the majority of the Indian coal which are found in India is among these particular three, the lignite, subbituminous and bituminous, some of them. But the anthracite having the most superior coal is the having a most carbon percentage more than 86 to up to about 98 percentage carbon. Very close to that of graphite. Graphite we know having a 100% carbon. So the next question is with increasing age of coal, what decreases and what increases? There are four options, different combinations. If anybody could try.
The final one. D.
Yeah. So the final one is the correct answer. The carbon content and heating value actually increases with the increasing age of coal, and that actually increases the rank of coal, and accordingly the calorific value and obviously the calorific value increases, and obviously the moisture content and volatile matters, these actually decrease with the rank of coal, and this directly correlates with the age of coal. So the correct answer is the fourth one. Now that is I actually also discussed that what type of coal is mostly found in the Indian subcontinent is peat anthracite, anthracite bituminous, peat lignite or lignite and bituminous. So as I've already discussed, not wasting much time on this question, is lignite and bituminous is a majorly found coal in the Indian subcontinent. Now the pulverized coal thermal processing in the thermal processing power plant, what is the output gas called? Is the producer gas, coke oven gas, flue gas or water gas?
Flue gas, sir, maybe.
Yeah, though the correct answer is obviously the flue gas, which we get actually after the output of the thermal processing of power plant. The next one is that we have been taught about the gross calorific value and the net calorific value. So what kind of what is the heat of water which is actually the difference creator between these particular two calorie values. Anybody?
Probably latent heat.
Yeah, the latent heat is the correct answer, because simply because the sensibility, what is the sensibility? Sensibility is that the amount of heat which actually causes the increase of temperature of any substance, but the latent heat would cause the change in the phase. It would not change in the temperature. So that is why the latent heat is the if we actually subtract from the gross calorific value, the higher heating value will get the lower heating value. So the latent heat is the correct answer. Now the characterization of coal, the proximate analysis, the moisture percentage is actually measured when we will be drying the sample for a certain temperature for a whole day, for a 24 hours. What is that temperature?
Walnut Fest.
Yeah, so the 105 degrees Celsius is the correct answer when we'll be heating it for 24 hours, and this will be the correct answer. We'll be getting the moisture percentage because the moisture will be removed, because it's nothing but a H2O, right? The H2O has a boiling point about 100 degrees. So little above this water boiling point will be ensuring that entire moisture will be removed. In a similar way, uh, now on a numerical problem for a coal-fired utility boiler, the temperature of high pressure steam would be about 700 degrees Celsius, and the cooling tower water temperature would be about 65 degrees Celsius. What would be the Carnot efficiency of the power plant? Very simple problem. Just I'd request you all to quickly solve the problem and tell me what would be the answer.
So maybe 35%.
And how we have got that? Can you just tell me what's the procedure? Anyone else, if they could solve the question? It's a very simple one. So the correct answer is 65%, not the 35%. And basically you have to be very careful about converting the both cold and hot temperature to the respective Kelvin scales, and then just simple 1 minus Tc by Th into 100%, and you'll be getting the simple about 65% would be the correct answer. Another numerical problem, if everyone is done with the previous one, if there is no question in that previous one, move to the next problem. It's the calculation of the water equivalent of a bomb calorimeter, which is having a 1.5 gram benzoic acid sample, which higher rating value is given, and the overall temperature rise which it actually caused was about 5 degrees Celsius, and the acid titration required 12 ml of standard alkali. When we mean the standard alkali, it means that there's a certain uh, concentration solution, so you'll just be going through that lecture. We'll be seeing that there's certain normal solution, and the 8 centimeter of wire was consumed in that particular firing. We have to determine the water equivalent of the bomb calorimeter. This kind of practice problems, and also in your whatever you have got in your assignments, those are very important, even if you are planning to go for a final examination also. So I have to be very careful about that. Please solve this problem, and then we'll discuss. Is there anyone who are getting any answers? Where are you stuck? Okay, so the correct answer is 2406.1 calorie per degree centigrade. How to solve this problem? This has been already shown in this in the lecture also, but I am again telling that the basically what happens is that when you are heating or in a combusting any sample in the bomb calorimeter, there is basically a temperature rise, sensible heat obtained by the worm, and also some heat is obtained by the water itself. So there is though mcp delta t, m bomb into cp bomb plus mw into cpw, and overall that there is a certain delta t, there is certain temperature increase. So these entire mcp bomb or plus mcp of water, this is actually called as the water equivalent. So when we trying to get the water equivalent value, we are getting this kind of formula, is higher heating value into the mass plus E1 plus E2 plus E3 divided by delta T. Now what is the E1, E2 and E3? E1 is the HNO3 correction factor. So basically if you are having some of the nitrogen or something, there will be some HNO3 formation. So we have to, that will be having some of the heat. So we have to correct it. So and accordingly, if there is some sulfur present, there will be some H2SO4 formation. So have to get that H2SO4 correction factor also. And again, there is a fused wire which is being used for combusting the sample. So that fused wire, when you are using, that would be having a certain heat energy released. So that fused wire correction factor is the E3. So the what would be the E1 value? E1 value would be the simple how much solution of the standard alkali will be required to titrate this particular amount of HNO3. Now we don't have any kind of H2SO4, so don't no, not to worry about the other acid. So the simple entire 12 ml of standard alkali is being used to titrate the HNO3 correction factor. So that would be the 12. There is no sulfur present in this benzoic acid, so that's why the E2 is nothing but 0. However, the formula is that the 13.7 into C2 into the mass of the sample. And the E3 is that the fused wire correction factor, which means that how much fused wire is being consumed in the particular reaction, particular combustion reaction, right? And it would be multiplied via a particular factor which is being actually calibrated via the types of wire. So for the nickel chromium fused wire, the factor we have to take is 2.3. In the lecture slide, it has also been shown that if you want to see also, yeah. So if you can see this this particular lecture slide also, you'll be able to see that the 2.3 is the factor for a nickel chromium fused wire. When you are using some other iron fused wire, that will be the 2.7, or the finer platinum wire, the E3 value would be 0. So for a nickel chromium fused wire, we're having this 2.3 value as a factor, and the 8 centimeter is the consumption of the wire. So putting all these values in the formula, water equivalent formula, and also the delta T is the 5 degrees Celsius. Not to worry about the Kelvin or degree Celsius, because this is delta. So when you are calculating, when you are putting a value of delta, it is same even in the centigrade scale or in the Kelvin scale. Ultimately, you will be having a value like 2406.08 calorie per degree centigrade. I have written it wrong. It's calorie per. It's not calorie per gram. It's calorie per degree centigrade. Another question is that if there is no doubt in the earlier numerical questions, we move on to another question. Okay, I assume there is no problem in solving those numericals. So during a boiler trial, the coal analysis on mass basis was reported as carbon 62.4 percentage, hydrogen 4.2%, oxygen 4.5%, nitrogen 0.4%, sulfur 0.2%, moisture 14.4%, ash 13.9%. If the ash molecular weight is 56, what would be the higher and lower heating value on as received basis? There is a certain correlation is already being provided. So what do you think would be the higher and lower heating value? Again, a very straightforward question. This is actually the direct empirical formulas have been provided here, and I have the values. I have to just put it. That's it. So this is the thing which I was talking about. You just have to put the values over this empirical correlation as is provided. You will get the high rating value, and accordingly, from that using that high rating value and the moisture and hydrogen percentage, you will be getting the lower rating value. If there is any doubt, please let me know. Okay. If not, some other problems which are actually discussed in the tutorial, the similar kind of problems which I have already discussed. There is that you have the tutorial lecture also, that the as received basis heating value determination, and also an extended version is that the molecular formula determination of the coal based on the composition given. So when you're trying to get the molecular formula, we have to convert it to the number of moles by having the molecular weight of the element, and that is why the ash molecular weight is needs to be provided, and that was provided. For moisture, you have to take the molecular weight as 18 as H2O. For sulfur, it has to be 32. Nitrogen has to be 14, oxygen 16, hydrogen 1, and carbon 12. You'll be getting the number of moles for a certain basis like 100 kgs of sample, and that would be your formula, the molecular formula. and that is entirely based on the as received basis. When you are trying to convert it to the dry basis, you have to, instead of uh, concentrating about the 100 kgs basis, you have to take the basis of 100 minus the moisture. So the basis would be 100 minus 14.4 here, and you will be getting that particular value of 72.89. So it would be like 62.4 divided by 100 minus 14.4. So in this way you have to get all the CHONS and ash percentage on dry basis. In the dry basis obviously there is no moisture, and in a similar way you might be asked to uh, derive the molecular formula in dry basis, dry ash free basis, like that. You have to like convert in that, like that. For dry ash free basis you would be having, you would need to be subtracting both the moisture and ash from this basis. And a similar way, putting these formulas, putting the values in the formula given in your question, will be having to solve the higher heating value in different kind of basis, whatever has been asked in your question. So has to be very careful about what kind of basis you are taking and what has been asked. It is dry basis, as received basis, dry ash free, and accordingly every answer would be changing. I would like to also point out one thing, that in the problem also there is this hydrogen coefficient is given as 1.16225 in this tutorial problem number 2. In the question the hydrogen coefficient is 1.16225, but if you put that value in this, when you are solving for higher heating value, you will be not getting this value because it has been wrongly given. This extra 1 before 6 has been provided, so it would be 1.6225. so please remember this. uh, it would be 1.6225 into whatever hydrogen is there instead of 1.16. so this particular value is, this one is extra, so that should not be there according to this particular tutorial problem. And the water equivalent determination I have already discussed, how to address this kind of problems, uh, similar kind of problems you might expect. And a similar thing that there is the earlier one was based on the ultimate analysis, the CHNS analysis. Yeah, and also if you are given the proximate analysis of coal and its whatever heating value is that, then you might also be asked to convert it towards the different basis also, moisture free basis or dry ash free basis. Similar thing you has to be, the basis correction would be there. So instead of 100, the basis would be 100 minus moisture, which is 2.9, 100 minus 9.7 is ash free, or dry ash free means 100 minus both of this 2.9 and 9.7, and then you will be having to solve. It's very straightforward one, and the similar factor you have to be multiplied with the calorific value also. You will be getting calorific value in the different basis. And the similar Carnot efficiency problem was also discussed earlier. There will be some, there might be some hot temperature and cold temperature would provided, and there will be, you might be asked to calculate the Carnot efficiency, and also this uh, for the Carnot one, I think yeah. So for the Carnot one, this is the 1.1 minus T cold by T hot is the basic formula. For if for other cycles such as ideal Breton cycle, you might be asked to calculate this particular efficiency, and you might not be provided with the temperature, or might be provided with the pressure instead. And in that case the heat capacity ratio, which is the Cp by Cv, would also needs to be provided. Even if these particular values are provided, you would be you should be able to solve for the efficiency of a, again, a ideal Breton cycle also. And also another tutorial problem which was discussed in this tutorial lecture was this particular fifth number problem. A very interesting one. It says that conventional coal-fired power plant costs about certain cost to construct an efficiency of 34%, but we construct an IGCC plant which would be costing more, about $200 per kilowatt, but there also in the cost of this extra $200 per kilowatt we will be having an extra 11% efficiency. So a certain heating value of coal is also provided. So if we need to recover this extra $200 per kilowatt, then in 5 years, then what kind of the cost of coal there should be, and time value of money should be ignored. So we have to solve this kind of, might be wanting to solve this kind of questions also. There in this particular thing there is a 5 years, so have to calculate that if we consider that the both plants are operated at full capacity for 5 years, the total hours of operation would be? There are 365 days for 4 years, and one obviously would be leap year in every 4 years, so 366 days. So total days into, if we consider this, it's 24 into 7 the plant is working, so into 24, so there will be total 43,824 hours. It means if for 1 kilowatt, it means the this would be the 43,824 kilowatt hour would be the total production of the production capacity of the particular plant. Then this particular, for this particular kilowatt hour, if we get the mass of coal, it would be nothing but the how much energy we're getting. This is the work, done into the divided by the efficiency into the heating value of the coal, right? So the heating, the for the general normal power plant, the efficiency is lower. For the similar, then the rest of the parameters are same, so obviously the efficiency is lower. It means that more and more mass would be required to generate the same amount of energy. So accordingly, putting all the values, 16.57 tons would be required for the normal power plant, and the IGCC power plant would be requiring 12.52 tons. And in this way, there would be a 4.05 tons of saving for over the 5-year period for each kilowatt of the plant capacity. And accordingly, if there is a $200 is the difference of price in between them, so if we divide it, the $200 divided by 4.05, it would be around $49.37. It should be the at least price, so that you can recover the extra payment we have made to build the IGCC power plant. So these are all the discussions which I thought I would have to make, and if there is any kind of discussions from your side or any kind of doubts you're having, please, the forum is open. The floor is open for question and answers. For the overall course, assignments, or what kind of normal doubts and lectures, tutorials. Okay, I assume that there's no other questions. I hope and remember the recording of the session would be available in YouTube. You can go back and check, and obviously you should check, because there are a lot of numerical problems have been discussed, which would be very much helpful for you. You'll be getting the, I think, the YouTube link, and if you have not obtained, please let me know in the next class. I'll share with you. So that's all for today. We'll meet again the next week. Thank you.
Thank you, sir.
Thank you, sir.
Thank you.